let's just start with what does NXP do? We'll start real simple.
Okay, so NXP is a semiconductor manufacturer of electronics, and semiconductors are electronic chips that are built on a material called silicon, which is a semiconductor. Those electronic chips are used in all aspects of your life. They operate in your car to make it function, to make it safer, to bring the radio and entertainment that you experience in your car. Electronics that go into medical devices such as diabetes, real-time monitoring and control, in the hospital, patient monitoring. They also apply to companies' factories as well as businesses to make them more efficient, or for payment transactions to make them more secure, as well as for fitness watches, wearables like the watch that I'm wearing, for richer displays, measuring biometrics for the different conditions that you want to do with sports watches, whether it's golf or running, as well as wearable devices that are more futuristic, like the glasses that we have, which contain cameras and speakers and recognition of voice that's powered by NXP technology.
When you say that it's like for your transactions to make them more secure,
yes.
I imagine you're talking about like credit cards and how they have the microchips in them now.
Right.
How do semiconductors play that role? How do they, is it programming? Is it, a combination of just kind of how much electricity is passing through?
Yeah. So again, semiconductors is a material where we produce electronics, and your question is really, how do the electronics enable a secure transaction? NXP has a long history as a leader in financial transactions, government documents, and also secure payment to get in a large football venue, where you use a radio that is called NFC, which is a near field technology from a radio, where you have you bring your phone or a business card close to a payment terminal, and then the information that's on there is secured on the chip in ways where NXP has expertise.
Kind of alluding to what you've been talking about, how important are these chips? We talked about how wide-ranging and just how far they reach, but how important are they?
Well, importance is at a very high level, and the question is why. Everything around the U.S. economy, anything around critical infrastructure, and even take it to just entertainment and devices you use to control your home, all have semiconductor chips in them to make them function in a way that you expect them to function and to do the things that they're designed to do. So the automotive industry in the U.S. is dependent on semiconductors. Medical devices are dependent on semiconductors. Factory operation is dependent on semiconductors. So the U.S. economy, critical infrastructure, and the experience of all the devices that we use in our life all requires these chips, which then becomes critical for the U.S. to grow local domestic manufacturing capacity, which leads to the recently passed CHIPS Act, which is great initiative to grow this domestic manufacturing capability. It also brings in higher technical jobs that are higher paying into our communities, and becomes just the more critical building block for everything that we do in life, making it healthier, making it safer, and performing the functions that we expect to have every day in our life.
When Congress finally passed the funding for the CHIPS Act, what was your immediate reaction to seeing that bill finally signed?
So we're very excited about it because it builds this critical domestic manufacturing capability that the U.S. economy and the infrastructure within the U.S. as well as the world economy is dependent on. And it will help create that capability in the U.S. that applies to many of the applications that we've talked about.
When we talk about the CHIPS Act, is this a feeling of finally the semiconductor industry is being recognized, or is it, was it a long time coming for you?
Yeah. Well, as you know, we've been in Austin for over 50 years. We have a long heritage as NXP from both Philips and Motorola that now make up what NXP is today. And we have been developing electronics that are impactful to your life for many, many decades. So with that as background, the CHIPS Act and what we can do with that investment as a community and as the U.S. is to continue to grow that capability in ways that are more advanced and more capable to improve safety, to improve quality of life, to improve the efficiency of running businesses in many, many different ways.
NXP has offices in Europe.
Yes.
Other places outside of the U.S.
Yeah.
How does the CHIPS Act level the playing field, for lack of a better phrase,
Yeah.
to bring companies, whether it's NXP or otherwise,
Yes.
here?
Yeah. Well, in the semiconductor business, in order to build a factory, it costs billions and billions of dollars. And in many regions of the world, those cost of building that capability can be subsidized, and many people drive incentives to attract companies. By passing the CHIPS Act, the U.S. is taking a step to bring that technology to the U.S. For all the reasons we've talked about, because the dependency on semiconductor chips and what they do for our life and our communities is pervasive now.
You mentioned NXP, previously Motorola, Philips, long history here.
Yes.
Central Texas has a long history in this industry.
They do, yes.
Can you speak to that a little bit and the role that this region has played in this industry?
Yeah. Well, to the first point, Central Texas has brought a lot of high-tech businesses into a single area, like a Silicon Valley. And they also are investing in different educational initiatives that helps build strong workforce population that can work in the factories and related jobs. Also, there's a university, very strong university capability in Austin and Dallas and throughout Texas that helps create an innovative environment. And then just take the Austin area as an example. It's a vibrant, rich community that attracts some of the best talent because of the quality of life and what this area in Central Texas offers people is attracting them. So it makes for good business. And then that whole community of university, of high tech, as well as the various different groups of industries and people together in the Central Texas makes for a very innovative environment, very vibrant environment for us to do what we do.
We were talking before about how everyone kind of knows each other in this industry. As much as it is a very pervasive industry, it's also small in that way, and it's a smaller community. What's the relationship that all these companies have with each other in this industry? Because they're all here in Central Texas. You have NXP, Samsung, Infineon. You have all the companies that are here to support as well. So what's the relationship there?
Well, there are many high-tech companies that work together, and therefore we interact to build the capability where we each bring different technologies and capabilities in place. And that can be a supplier of mine that is providing me parts of the building blocks that we use to create the electronics that we then sell, or it can be competitors of NXP, where in some cases we have complementary businesses. It brings in a larger workforce, but the interaction in the community and driving standards, for example. So a great example would be for smart homes. How frustrated do you get when you try to bring in a new device or thermostat or a speaker and you want it to seamlessly interact with your home and you're struggling with figuring out how to have it recognized and operate? Some of the standards we create, like Matter, which is a home interoperability standard, are targeted at getting communities and leaders from these different companies together to align on a standard, so the end user experience where you're not differentiating your product, but you want all products to work in a similar manner, can come together and be realized because we work together.
The past 2 years or so, give or take, semiconductors have really made a lot of headlines, especially in relation to the supply chain challenges that have faced the industry. Do you think the general public understands what you do?
So it's a great question. Even with friends and family, you can say, I make semiconductors, and they just acknowledge and then move on, but they really don't know what you do. Now people understand that semiconductors are important. They understand that in order to deliver semiconductors to your needs and desires, that you have to plan far ahead, because the time to produce new semiconductors is very long. This is a fairly complex process that takes time in order to produce it, and how relevant and impactful it is, because when you don't have something that you've ordered and you want it quickly, or infrastructure that's critical needs electronics in order to support fire and safety, as an example, you then realize how important it is to have it when you need it, because it impacts our community. So there is a much greater realization of what semiconductors are in terms of these chips, which is now a popular term, and what chips do in terms of all the devices that you wouldn't necessarily have thought have electronics in them. You would look at them and think about them in a different way.
Over the past couple of years, I've kind of heard, chips is kind of the umbrella term.
Yes.
But when people ask me about, stories like this,
Yes.
they ask, are semiconductors computer chips? Or is there a different, are semiconductors kind of an umbrella term,
Yes.
where computer chips are a bit more specific?
Yes.
How do you answer that? I mean, are they the same? Are they interchangeable terms, or not really?
So the easiest place to start is to say electronics, which are electronic chips, are produced on silicon. And silicon is just as a material, which you can see here is a silicon wafer. This is a semiconductor. Okay, so a semiconductor, so if you look at a wire, it conducts electricity. If you look at an insulator that we all know, it doesn't conduct electricity. A semiconductor has properties where you can turn it on or turn it off, so it can act like both. And what you do is you take this silicon and you create these little structures like switches, wires, capacitors, and you put billions of them on a single device that then produces the effects that you experience on a mobile phone, on an advanced thermostat, on a voice discussion with your favorite voice system. All is based on semiconductor-based chips that are prevalent in your life.
It always shocks me how small they are.
Yes.
What's the benefits of the size? What are the challenges of that size?
Okay, so let's talk about the size just to put it in perspective. Okay, take a human hair. Look at the width of a human hair. Divide that width in 1,000 equal pieces, and one of those pieces is the size that we're operating on in a semiconductor electronics device. And what you do with that size, which generation after generation you make it smaller, and then you pack more circuits or switches and capacitors and resistors onto this device here that then performs the function of a little computer, or it's sensing biometric data and it's working together to then change your temperature, actuate. So that's the size, and the challenge when you produce that is getting everything right and eliminating any type of breakage or any type of contamination that could affect the performance of that. And to put that in perspective, a skin flake is devastating at that size. So as you go into an advanced semiconductor facility, it is designed so that the amount of particles in the air are so small and so few that they can't affect this, which is why a semiconductor manufacturing factory is so complex and so costly, is because you're producing very small images and you need to keep the environment in the purest state in order for the end product to function.
Okay. What are some of the other challenges that face the industry as a whole? I mean, we see all these companies expanding, through Chapter 313 agreements or moving buildings here or what have you. Everyone has to pull from the same resources right now, right? I mean, I imagine that presents its own challenges.
Well, the great thing is the demand for semiconductors is increasing. The benefit of producing these more advanced technologies and what they can do for us in our life is becoming more impactful. And growing that industry requires higher education, higher skills, and that's why the various initiatives at the university level, at the community college level, and at the high school, as well as STEM education, becomes very important. So it's building a culture around this science and technology that then leads to a very robust industry and is very impactful to our economy and to our communities. And so it's the companies working together and working together with the universities to really grow that capability. That becomes absolutely critical. And then initiatives like the CHIPS Act to incent investment, where we're building factories that are capability to produce these semiconductor chips, as well as the tooling and capability to support the creation of these, which is a set of companies and industries that go far beyond just producing the wafer.
When we talk about this industry and the growth that it has, do we also need to see an equivalent or similar growth in terms of the infrastructure that is here in Central Texas or the state itself to support that growth?
Yeah. So absolutely, it is critical that there's continued investment in the infrastructure, the materials, the electricity that are needed to maintain factories operating 24/7, continuing to operate and control those conditions we talked about to keep it in the purest state so that the very small structures aren't damaged when you're producing these semiconductor chips is very critical. So continuing to invest in infrastructure that is stable and resilient is important to the industry. It's important to the economy because as these factories stop running, they stop giving output of these semiconductors chips that impact many people around us.
You mentioned earlier that that chips are getting smaller and smaller and smaller, and you're putting more and more, transistors, insulators, et cetera, onto those.
Yes.
Can you talk about how research and development and production do they go hand in hand? Do you have to prioritize one over the other?
Yeah.
Is it kind of cyclical in that way? Yeah. Can you talk about that a little bit?
Sure. Well, there's a concept called Moore's Law, where you're continuing to increase the density of circuits and the rate at which that occurs in the industry. And that is achieved by introducing year after year after year the latest generation semiconductor technology. That takes a lot of research that has to understand what does it take to manufacture in a very efficient way and make that part of the research and development activity to then introduce that next generation of technology. So it is a critical need for both the researcher and the manufacturer to talk, because the time that it takes to develop one of these technologies is years. And you can't create the technology and then consider what it takes to manufacture. You have to develop the technology with the knowledge of what makes successful manufacturing occur. So it's a combination of them working together from the very beginning to the very end.
As the head of global sales,
Yes.
you might be uniquely qualified to answer this next question. You mentioned earlier about kind of the demand that's at play here, constantly increasing, but it also takes a while to make a chip or finish the production of a wafer. How much predictive modeling, if that's even the right phrase, do you have to do to say, okay, we think this is what the demand's going to be in 3 months, 6 months from now. These are the resources that we need now to prepare for that.
We work with customers around the world, which includes a significant customer base in the U.S. And with those customers in the different industries, automotive, NXP as a leader in the automotive space, as well as industrial and more consumer-oriented products, we serve in terms of our end products. We work closely with those customers to forecast their needs, and they forecast their needs based on market demand and what they use for modeling that demand. That all then comes back, and we have a very structured process to look at demand, to look at supply, and plan both from a strategic as well as a tactical horizon focus, how to plan what we are going to produce, and that the output then maps to those customer requirements. And we work on that on a regular basis as part of our operations to efficiently output it. The challenge is when someone says, I need 2 times that amount of demand and I need it tomorrow. Well, the timeline to just produce a new chip could be 3 to 6 months. If it's not on a technology or the technology is sold out, to produce a new factory could take 2 to 3 years. So, and if you're inventing a new technology with the research and development that we talked about, then that adds even more time. So the time to invest through some of the initiatives like the CHIPS Act is opening up the opportunities to drive that, is far ahead of the actual demand requirement and when you actually ship final product to those customers that are building the medical equipment, that are building the cars. So you have to also invest in a very strategic way, both within different economies and different regions of the world, with the understanding that that future demand and need and use of these electronics is going to just continue to increase and increase and increase.
How do global events kind of throw a wrench in the wheel of all that planning?
Well, it's like everything. You have a way of operating, and if something disrupts that way of operating, you have very talented people that focus and work on what are the ways to solve the problem. We've been doing that over the course of the pandemic and finding very creative ways to work together and continue to output to the level where we're outputting more chips than we have output in the history of the industry.
In the 90s, the United States was producing 30, 40% of the world's chips. We're now down to about 12, 13%-ish. How much would it take to even bring that up to making 15% of the world's chips? I mean, that it sounds like it's a little, just like 2% or 3% increase, but that's I imagine a pretty big lift, yeah? Or
so it's hard to turn it into exact numbers. We're taking the first step in the U.S. with the CHIPS Act to start to bring in more domestic capacity for semiconductors. And the growth of semiconductor use is very high. In all the things around you that you see are using little computers and sensors, and that is growing. And the content in a car for electric vehicles is growing significantly. So just the number of electronics in a single device, which you call a car, is growing. So you have this fast growing demand, and you have infrastructure that is being put in place through the various announcements that companies are making. And it will be a continued evolution of bringing on more capacity, new capacity over the years.
The CHIPS Act brings up $52.7 billion, I think. And that's just for incentives and what have you. To build a new factory is 15, 17, 20 billion dollars. So 52 billion in the grand scheme of the industry, kind of a drop in the bucket almost. How much does the industry need consistent investment from the federal government to keep up or to level the playing field, as opposed to, this one-time injection of opportunity and cash?
That's a hard question to answer in terms of quantifying it, but as you said, a single factory is billions and billions of dollars to build. And we're going to continue to have an increasing need for those factories to support what's critical for the U.S. economy, or for any economy that's looking at what they want domestically versus what they want to source and import. So it's really a question of regional strategy and how much capacity you want, and the strategic long-term investment never ends, because you need the new generation and then the next new generation, and then you're creating capability that's more and more advanced. So if you think about what your phone did in the past when you were young, whether it was a rotary dial, whether it was a push button, or whether you grew up with a cell phone, and you think about what a smartphone does today, and same thing with a car. The experience is so much different, and the capability is so much different, and that will not end. It's only going to get more advanced, more capability that is going to be meaningful in terms of what you expect in your life, and helps you both from a health point of view, from an efficiency point of view, even from an entertainment point of view. You're going to want more and more of that capability.
On that same note,
yes,
what do you think the future of this industry is? I mean, it's growing so quickly, and there's so much demand.
Yeah.
Where do we go from here?
Well, I'm going to answer that question from this perspective. There was a period in the semiconductor industry that was very focused on PCs. There was another phase that was very focused on cell phones. Now we're going into a phase of the industry which I call the age of edge computing, and that is the idea that there are many, many, many devices using electronics computers to do useful things. They're being deployed in factory, they're being deployed to make healthier livestock, healthier milk, healthier farming output. They're being deployed to extend quality of life in your home through different types of devices, and it's going to continue to be adopted in more different forms that you're going to desire to have, and is going to be beneficial for you to have in your life. So I see a phase of the industry where more electronics, more capability, which is software, hardware, and then the ease of use of those devices is going to become more and more prevalent. So it's an exciting time on how we use technology to do positive things for you in your life. And there is more and more to do with very cool end applications that are just exciting to be part of.
On the flip side of that coin, as we continue to progress, certain technologies or chips or what have you will inevitably get left behind. Is there any thought right now as to what happens to those? I mean, just in terms of recycling or disposal of these electronics.
Well, there's various aspects of this discussion. One is the use of older generation semiconductor technologies versus the most advanced technologies. But when you think about these electronics that we produce, some of the content that we make that go into these chips, it doesn't scale easily, because if it's sensing, if it's a radio and the way the radio is built, those different functions don't easily reduce in size. And so older technologies, when you combine things like radios and sensing technology, combined with digital computer concepts or capabilities and circuits, they fit into the older generation technologies, and they're much more cost effective than trying to force them in the most advanced. So each of the generations produce chips similar to NXP, where you need to use a combination of many different technologies based on the characteristic of the products that we're producing. And then you optimize what you build and where you build it. So I have products that I ship for 20 years into infrastructure, and they would like me to produce it for 20 more years. So it's a very long life cycle for certain applications. And in other applications, if it's more consumer, it may be a short 3-year life cycle. And then you need to discuss what people do with those devices once they're finished with them.
What's the per unit cost on a chip? I mean, there are, on that wafer, thousands, potentially, chips. I mean, is that even, or is that even a unit of measure that you consider as kind of that per unit, you know, each chip is like, I don't know, $1. That's...
No. So let me put it in perspective. The products that we produce in a semiconductor technology can be very, very small to a very big device or product. And the price range can be in the cents, it can be in the dollars, it can be in the hundreds of dollars, depending on what you're producing and what you're selling into a market. So there's a wide range of semiconductor products, and there's a wide range of the cost of those products depending on what they do.
You've been in Austin for 14 years?
Yes.
How has the industry changed, or how has the semiconductor scene changed here?
Well, over the 14 years, and I've been working in terms of activity in Austin for longer than that, but over the years, Austin has attracted a much richer, high-tech community, a broader coverage of technology companies that produce equipment that supports semiconductors, that creates applications on top of semiconductors, which can be software and services that go along with semiconductor products, as well as the factories that have been built, both what NXP has in its 2 campuses with its thousands of employees, as well as some of our industry partners that also build facilities here in Austin, for which we're a customer of theirs because we use their technology to produce our products as well. So from that perspective, the high-tech workforce and the people that are in our community have grown significantly, which makes it a hub now for high-tech around the world coming to Austin to work with both NXP and the other companies that are here. So that's been a key change. The talent that's being attracted to this community has increased dramatically, and then the infrastructure around has built up to support the community and become a richer and more exciting place to live.